Hello and welcome to the answer key for your final exam review. So let's just get started, get this thing through. These are complex numbers. I'm going to start by distributing the negative to both of these terms, and that's just a matter of adding up like terms. So negative 12 and negative 17 give me negative 29. 7 and 9 give me 16. That would be I. The big problem with this one is a lot of people forget that when you multiply negative 4i times 4i, you get negative 16i squared. So hopefully you can remember the I squared is special because it becomes negative 1. We get 9 plus 12i minus 12i minus 16i squared. Those cancel each other out. End up with 9 plus 16. Remember, I squared is negative 1. That gives you 25. Okay. You can also do this kind of stuff or double check yourself on the graphing calculator. Remember, you can get to I with the second key. Oops, there we go. So parentheses 8 minus 5i. I is above the decimal point. Right parenthesis, then squared. I still want to see the work, but you should end up with 39 minus 80i. Let me give you a reminder / hint. When you're doing this problem, some of the first work that I expect to see would be for you to repeat the binomial. That is for you to write 8 minus 5i times 8 minus 5i. Another big mistake people make is that they make one of them plus. If you're squaring something, you multiply it by itself. Let's move on down to problem number 2. I expect you to do this one on Desmos or the graphing calculator. So what you got to do first is find the coordinates of these points of intersection. So let's see if we can't do that. Plug the formulas into your graphing calculator. I think I've got them both here. X cubed plus 3x squared minus x squared plus 5x plus 7. Let me graph those. I've got this up here for later, so I'll shut that off. For my window, I think I've got my window set up the way I want to. So there's my window settings. And let's graph it and see what we get. All right, so I need to find these 3 points of intersection. You can do that on your graphing calculator. You can do that on Desmos. Intersect. So the first curve, let's take a guess at negative 1, negative 2, negative 3, negative 4. I'll guess at negative 4. Whoops. Let's try that again. Graph. And then intersect. Negative 4. Darn it, it's not doing that. Not doing what I wanted to. So I guess I have to cursor over there. Second calc, intersect. And let's just cursor that way. And press enter a total of 3 times. You just got to get somewhat close. 1, 2, 3. So the intersection is negative 4.743. 4.3. I need to find 2 more points of intersection. So let's do that again. Second calc, intersect. And this time I want to go over to the point by negative 1. I want to type that in. I'm not sure why it's not working. So I'll press enter a total of 3 times. That third time gives me intersection at negative 0.899. And last time, let's see, second calc down to number 5. One last time. Let's go over to the point near 2. You just got to get somewhat close. I mean, that's close enough. Press enter a total of 3 times and 1.642. 1.642. Let's cut back over to our viz camera here. That's right there. And let's see. We want to know where f of x is equal to g of x. So that's going to be these points, negative 4.743, negative 0.899, and 1.642. This problem is actually leading you towards the right answer. Now, the second part is I need to know where f of x is greater than g of x. So that's going to be where this function lies above g of x. And that's going to happen starting right here. So here to here and here to infinity. So that's going to be negative 4.743 to negative 0.899. Now, since this is a greater than or equal to, I'm going to include those endpoints. Union here, 1.642 to infinity. All right, looking good. Let's keep going. Next, I want to solve this inequality. So first of all, I need to figure out where it's equal to 0. So that's going to be at these points at, for instance, negative 3 and 2/3 and 5. That creates intervals along the x-axis of negative infinity to negative 3, negative 3 to 2/3, and 2/3 to 5, and finally 5 to infinity. Plug that into your graphing calculator and do some testing. So let's take a look here. Let me clear out all this stuff. I'll clear this out first. Then clear this out. Let me change the function in my graphing calculator. I'm going to shut this one off by pressing the Enter key over the equal sign. Shut that one off. Now turn this one on and go to the table. I want to do some testing of points. The points that I want to test are points in each of these intervals. So I'll delete all these things here and go back and look at what could be used as good test points. So my test points could be things like negative 4, 0, 2, and 6. So that should give me a negative, positive, excuse me, positive, negative, positive, positive pattern. I'm guessing it's negative 4, 0, 2, and 6. Okay, so that's what I expected. That's what I got. The reason you're getting the positive positive there is because of the square term. You get a bounce if you were to look at the graph. So it touches the x-axis, but it remains positive. So positive, negative, positive, positive. If you keep in mind that we want to know where this is less than or equal to 0, that means we want this interval here, which is going to look like negative 3 to 2/3 with brackets. Hey. Let's keep going. This is just a notational thing. So it's asking you, do you understand what f of x squared is? That would be 3 times x squared minus 7, or 3x squared minus 7. In contrast, this would be 3x minus 7 squared, which is 3x minus 7 times 3x minus 7. That's going to be 9x squared minus 21x again, which gives you minus 42x plus 49. Nice. Net change in the function, that's just going to be, kind of a delta y is what I've called it before. That's going to be f of 5 minus f of 0. 5 cubed is 125 plus 15 is going to be 140 minus 0 is 140. Delta y divided by kind of delta x, basically that's going to be f of 5 minus f of 0 over 5 minus 0. Well, we've already calculated that above. That's 140 divided by 5 is 28. Going a little further, if you want to find the average rate of change in this general sense, this is a calculus type question, so it's paving the way for things to come. I'm first going to find f of x, or excuse me, 3 plus h. So let's put that into this. This can be 5 times 3 times 3 plus h squared. Let me square this out this way. It's going to be 5 times 3 minus, you'd have to do 3 plus h times 3 plus h, which is going to be 9 plus 6h plus h squared. And then probably distribute the negative 3. That's going to be 5 minus 27 minus 18h minus 3h squared. Combining the 5 and the negative 27 gives me negative 22 minus 18h minus 3h squared. Okay. That's f of 3 plus h. What about f of 3? F of 3 is simply going to be 5 minus 3 squared, which is negative 22. Overall, to calculate this, what we need to do is we need to calculate this expression, f of 3 plus h minus f of 3 over h. That's what we need to calculate. And in general, you're going to be calculating f of a plus h minus f of a over h. A is the number in particular that you're going to deal with. So let me calculate that difference in the numerator, call it delta y again, f of 3 plus h minus f of 3. That's going to be this monster. So that's going to be negative 22 minus 18h minus 3h squared minus negative 22. The double negative makes it positive. That's going to cancel out. You're going to get negative 18h minus 3h squared. There's one last thing to do, and that's divide this by h. So if I divide that by h, I can factor out the h. It's going to be h times negative 18 minus 3h over h. The h's cancel, and we get negative 18 minus 3h. And that's your answer. Yay. So good on us for that one. Moving on to problem number 7, another inequality, this time a rational inequality. Before we do anything, we've got to write this with one expression. So that means getting common denominators. So let me rewrite this a little bit. The common denominator is going to be x plus 5 times x plus 2. So from this expression, I'm missing the x plus 2 term. I'll multiply by x plus 2 over x plus 2. From this expression over here, I'm missing the x plus 5. So I'll do both of those. Then what? Then this gives me a common denominator, x plus 2 times x plus 5. I've got x plus 2 here and 2x plus 10 here. X plus 2 plus 2x plus 10 gives me 3x plus 12 over x plus 2 times x plus 5. And I want to know when that's greater than or equal to 0. Well, first thing first, I've got to decide where this equals 0 in the numerator and denominator. So the numerator equals 0 at 3x plus 12 equals 0, or x equals negative 4. Denominator equals 0 at, well, I hope you can read that off, at negative 2 and negative 5. Let's put those on a number line. So in order, there'd be negative 5, negative 4, and negative 2. That creates intervals of negative infinity to negative 5, negative 5 to negative 4, negative 4 to negative 2, and -2 to infinity. One or more of these intervals is going to be my answer. I need to test points. That means taking this expression here and put it in your graphing calculator. Now, I've already done that in two different ways. So let's take a look at those. The one way that's easier is if you can remember to hit the alpha key and then the y equals key. That first option there allows you to draw a fraction like I did with y1. Let's go back here. The second option is just use parentheses around the numerator, denominator. Notice I need to use a double set of parentheses around the denominator. With your table setup correct, like this, then go to table. Let me delete all the points here. I need my new test points. Let's see what those should be. I need points inside each interval. So that would be points like this one, -6, -3.5, -3, and 0. So those would be good test points. Let's plug them into our graphing calculator. -6, -3.5, -3, and 0. Yay. So it goes negative. Let's see, that's weird. Negative, 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 and then positive. Something looks wrong there. So the problem is that I wasn't paying attention. -3.5 is not between -5 and -4. What caught my attention was that usually when you do these problems, you get a plus minus kind of pattern, an alternating pattern. We didn't get that. So I started getting a little suspicious when we were looking at our table results. Let me go back and type over this, -4.5. That should give me a pattern that I expected a little bit more. Again, all we need to know is plus minus. Looking back at the problem, we wanted to know where this was positive. So we got negative, positive, negative, positive. And so we want the positive intervals as part of our answer. So that's going to be this one and this one. Now, the question is, can we use the endpoints? Well, you can't use any endpoints that make the denominator 0. So we can't use the -2, we can't use the -5, but we can use the -4. So we'll include that with a bracket. It's going to be -5 to -4 bracket union -2 to infinity. A -2 gets a parenthesis because we can't use that in the denominator. Infinity always gets a parenthesis. Likewise, -infinity. Let's move on to this one, where really there's not much in the way of calculation. It's just a matter of, do you understand some of the things that are being asked? We'll start with the domain. The domain is your x values. So that's going to be here along the x-axis, all the way out to here. Now, I forgot to put a point there. So yeah, there we go. Let's just estimate it at 3.2 and -7.8 for purposes of this calculation. Now, for the domain, it starts at -2.5. But we're going to include that with a bracket, and it goes all the way up to 3.2. 3.2 gets a parenthesis because that point is not actually there. In terms of the y direction, the range, that's going to be from lowest to highest. So it's going to be this direction along the x-axis, along the y-axis, all the way up to here. And we're going to get down to a low of -7.8. Again, -7.8 is not on the graph, but 10.128 is. That gets a bracket. Local minimum, the y coordinate. Please don't give me the x coordinate. I just want the y coordinate. This could be negative 4.128. And the local maximum, likewise, is going to be 10.128. Increasing, where is it increasing? Well, it starts increasing right here at negative 1.528. It's going to keep on increasing until it gets to 1.528. Outside of that, it's decreasing on the interval negative 2.5 to negative 1.528, and also 1.528 all the way down to 3.2. Notice that these are in terms of intervals along the x-axis. Is the graph a function? Yeah, it passes the vertical line test. Passes BLT. So yes. Estimate where f of x is greater than or equal to 0. Well, let's see. There's a little bit of an interval right there. So negative 2.5 to negative 2.398. And well, I don't think there's really much in the way of estimating. By the way, that should be a bracket. And then negative 0.441 to 2.838. By the way, another question that I could ask is whether or not this is a one-to-one function. It is not, because it fails the horizontal line test. So another good question that you could ask on this. Okay. Hope these are going well for you. Let's do a couple more here. Let's see. This is just notation. F plus g of 2 is f of 2 plus g of 2. F of 2, 1, 2, 3. F of 2 is 3. G of 2 is 5. For a total of 8. Now over here, this one works a little bit differently. F of 2 is 3. So we'll start by saying, okay, well, I'll replace f of 2 by 3. And then we're going to have to find g of 3. That we're going to have to kind of estimate. I'd say it's about 5.3. Let's just double check that. So 1, 2, 3, 4, 5. Yeah, it's between 5 and 6. Less than 5.5. So 5.3, 5.4, 5.2. I'll be pretty generous of that. The domain of f, that would start at negative 1 and go all the way up to 4, 6, 8. Negative 1 to 8. Let's just assume that these are closed on either end, so that those are closed here. Is this a one-to-one function? Yes. Passes the horizontal line test. So let's just call that the HLT. As far as the inverse is concerned, instead of the point 0, 2, we're going to draw the point 2, 0. Instead of the point 2, 6, we're going to draw the point 6, 2, and so on. And then just connect the dots. You should get something that's the mirror image of your function around the line y equals x. So if I draw that line here in the center, y equals x, you should see that one of these graphs is just the reflection of the other one. There we go. Y equals x. Beautiful. Domain and range of f. Domain is 0 to 6. The range is 2 to 8. Now for the inverse, these things are switched. So the domain of the inverse is the range of the function. So it's going to be 2 to 8. And this is going to be 0 to 6. Beautiful.